Hi all, so this is a walkthrough of a structure determination question which includes data for IR and NMR. This is one of those type of questions where students find it difficult. It is part of this year 2 or year 13 syllabus. Hope it helps. Please ignore any reference to booklets that are mentioned in this walkthrough. Unless you're my current student or have been in the recent past, you will not have these booklets, so obviously ignore all the reference to booklets and question numbers as well. Okay, thank you. Okay, so this is another walkthrough for chemistry A-level question. This is based on structure determination. If you have one of our booklets, structure determination booklets, this is going to be one of the exam questions at the back, question 6B. The reason I'm going through this walkthrough is someone's requested it, some of you requested it, how to do these questions, especially where they've given you sort of multiple sort of chromatograms, different techniques, so infrared and NMR. And remember what I said to you, the whole point of me doing these walkthroughs is to show you my sort of thinking process that I go through in order to answer these questions. And the fact that this has got 9 marks, actually, okay, the good news is that, it's easy, some of these marks will be easy to get. And the bad news is, it's a lot of marks, a lot of information is needed. But you should not panic, when you see a question like that, okay? Let me show you how you approach this question. So the first thing I need to realize is that so look at the molecule, that is important, that is your friend, okay, as they say, the molecule, the formula is your friend. So the first thing I'm going to do before I do anything is I'm going to, and by the way, I am going to have this question either at the beginning of the video or somewhere at the top if I can manage it. But anyway, it's in your structure determination booklet. So the first thing I'm going to do is I'm going to put down C6, H14, and O2. Okay, so that's my molecule. The next thing I need to do is I need to look at the IR. And the first thing, even before, if you notice I put down OH here, the first thing I do is whenever I see IR is look for this broad peak. If there's a broad peak, I know there's an OH. Okay, whether that's due to an alcohol or a carboxylic acid, I don't know yet. I'm going to have to look at the data table. But however, that broad peak gives me hope because I know I can identify at least one functional group. Okay, and that's OH. All right, so let's do that. Okay, so this, now when you read this, you've got to be fairly accurate, the wave numbers, So that's 1, 2, 3, 4, 5. So that's 3,500 there, so that's 3,400. So the peak is 3,400. So I'm going to put that down. So IR equals 3,400 per centimeter, and that is a broad peak. Okay, and that must be due to an alcohol. But which alcohol? Well, let me have the data table, and of course you'll be given this data table. Table A, it says OH, so OH 3,400 lies between that. It lies between that, but we know there's no nitrogen in our molecule, right? So we can ignore that. OH 3,400, just to confirm, is there an OH? Yep. OH for the acids, is not. 3,400 does not lie within this range. All right, so this must be for the alcohols. Which alcohols? Okay, so I'm just going to continue with the question. So the proton NMR contains 5 peaks, the chemical shield, blah, blah, blah. Okay, so this is a good thing that they've given you this table. So the NMR in this table format, because those people who know me know that even if they'd given me an NMR spectra, the actual spectrum, I would still translate that spectrum into this table to help me organize my answer and try and get as many marks as I can. Okay, so the fact that they've actually given me this table, that's actually good. The other information they've given me is when R is warmed with acidified potassium dichromate, a green solution is formed. Okay, so now immediately I'm thinking potassium dichromate is an oxidizing agent, so obviously whatever we've got, it must be oxidizable, right? Because it's changing from orange to green solution. Okay, so immediately I'm thinking, okay, so that makes sense because we just got that as an alcohol, right? And of course we know potassium dichromate, they can oxidize alcohols, primary, and secondary, but not tertiary. All right, so I might as well put down it's probably a primary or a secondary alcohol. Okay, it can't be tertiary, all right, because tertiary wouldn't happen. Right, and then move on, and then it says use table A and B on the data sheet and all the data provided in the question to deduce the structure of R. In your answer, explain how you've used the data provided in the question. 9 marks. Okay, so in this kind of a question, you've got to use all the data given to try and explain why you're getting to the structure. Okay, I've already used IR. All right. The other thing I could, I suppose, add in IR is I know it's not an acid. Carboxylic acids have C double bond O. All right. So and I can see that between 1600, so 1680 to 1750, so 1680 to 1750, there are no peaks, and I might as well say that. Okay, so no peak at 1680 1750, and therefore, okay, no CO, therefore not a carboxylic acid. Right. So okay, so that's that done. I don't think I can get any other information from the, I mean, I can maybe get something from there, but we'll see whether we need it or not. Okay, but I've got a couple of pieces of information from the IR. Let's move on to the NMR. Right, so you don't probably need to do this in the exam. I'm gonna transfer some of this data onto my sheet here. Yeah, just so it helps me explain and go through the answer. Right. So chemical shift, there is a 3.8. Okay, so that's my data. Okay, let's start thinking about it. So now, what I'm going to do, and actually, before I do anything, what I do is this. You see this integration ratio? These are supposed to be ratios. So hydrogens in this environment are 2 to the ratio of 3 to the ratio of 1, and so on. So what I want to know is whether these are ratios or do these correspond to the actual number of hydrogens that are present in each of these peaks. And the way I do it is add all these hydrogens up. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And so that adds up to 14, which is exactly what we have in the molecule. So even though these are ratios, but these are going to be the actual hydrogens in each environment, each of these environments, okay? And that's something to keep in mind. Right, let's move on. So let's now start looking at individual environments and fragments. What do they correspond to? All right, so if you look at 3.8 and 3.8 in the proton NMR, because that's what the question says, yeah, proton NMR. So proton NMR, and then it says 3.8. Now 3.8, yeah, it could be ROH, but the point is, if it was an ROH, it wouldn't have 2 hydrogens there, so it can't be a hydroxyl group here. So 3.8, it can't be that because there's a, we don't have a nitrogen in our molecule. 3.8, yeah, that could be that. It can't be that because there's we don't have chlorines and bromines. 3.8, it can't be that because it's not an ester. An ester wouldn't be oxidized by the potassium dichromate. So 3.8 looks like that fragment. Okay, so I'm going to draw that fragment here. Okay, now remember, this data table shows you just a single hydrogen in each of these environments. In my actual compound, I might have 3 of these hydrogens here, or just 1, or just 2. Yeah. So what I need to do is I need to now look at the integration for this environment and find out how many hydrogens there are. And we already realized these are the actual number of hydrogens, not ratios. So I can actually put in the 2 hydrogens. One is already there. I can put the second one here or the second one here. However, what I do is I tend to leave the trading bonds, yeah, because the trading bonds then help me to actually arrange in a jigsaw type puzzle near the end when I'm trying to join various fragments together. So I always leave these trailing bonds. Okay, so that is 2 hydrogens for this environment. Okay, now as soon as I've done that, by the way, I'll go through the mark scheme later, but as soon as I've done that, you'll notice that will give me a mark. Okay, let's move on to the next one. So 3.2. So the 3.2 is, again, it can't be that because we wouldn't have 3 hydrogens for that. So it can't be that. 3.2, 3. Right, I'm coming back to that one. Yeah, so I'm coming back I'm coming back to that molecule here, that fragment. Okay, so I'm going to write that down again. So I'm now saying, okay, there's that. This time, how many hydrogens does this have? Oh, it's got 3 hydrogens. Okay, so that's okay. So now I've got to make sure there are 3 hydrogens on my fragment. Leave the trailing bond that is as it is. 3.1. Okay, now this is quite downfield as well. So we've not had an OH yet. So I'm assuming it can't be these two. These are very upfield. Yeah. So OHs are usually downfield anyway. More electronegative atom, oxygen bonded to it. So I'm going to assume that it's OH, but let's just confirm anyway. So yeah, 3.1. It could be from that. Can't be that because we've used it enough times anyway. No, it can't be that. So it has to be that. So let's just put that down. And that makes sense because it's got 1 hydrogen and it's a singlet. And we know the OHs do not show any splitting patterns, yeah, in the NMR. Yeah, so hydroxyl groups do not show splitting patterns in the NMR. Let's go on to 1.4. So 1.4. 1.4. So it could be R2CH2 or it could be R3CH. So R2CH2. So the way I'm going to draw it is that, or it could be that. Right? Now, I'm thinking it should have 2 hydrogens. If I do this, it's only got 1 hydrogen here. It's got to be a carbon. That's why they've said R's. Yes, it's got. And if I put carbon, carbon, carbon here, I can't put a second hydrogen. So this cannot be the fragment. So it has to be this one. Okay. Let's look at the last one, 1.1. So 1.1 is 1.1, 1.1, 1.1. No, it can't be that. 1.1. Well, it has to be that, isn't it? Right. So RCH3. So it's going to be CH3. But there's an issue, a little bit of an issue, because what you'll notice is that there are 6 hydrogens. We only got 3, and usually when that happens, that means there are 2 CH3 somewhere. Okay, I put 2 small 2 here, but you know what? Maybe we should do is we should probably put there because I'm not saying there's a CH3 2 of that. But anyway, I think that's in a molecule, used in a molecule, isn't it? So what I want to say is there are 2 fragments. They might be in different places completely. Okay, but anyway, so let's move on. So now that I've got these fragments, now we come to the relatively easy part, because now we need to join all of these, yeah, fragments like a jigsaw to see how they fit. Right. First thing I think about is, hold on, I've got 1, 2, 3 oxygens, but in my molecule there are only 2 oxygens. So 2 of these oxygens are the same ones showing from different aspects. Okay, and immediately I'm thinking this one and this one is probably the same. Obviously that OH, it could be that hydrogen's bonded here, but then that would be the end of the molecule. What else are you going to join afterwards? So it could be that this and this is the same. It's just that this is being shown from this end, and this is probably being bonded from that end. Okay, so I'm going to start with that because that's a nice place to start. Why? Because that looks like the end of a molecule. Okay, so I'm starting from the end of the molecule going that way. And of course, there's the oxygen. I'm going to assume that that oxygen is the same as that, and therefore on the other side, there's that CH2. All right, and a trailing bond. So that's that. So I've taken that into account, done that. Now, if I start adding that here, OH, that would be the end of the molecule, where I'm going to add all these. If I start adding that at the end, I'm only going to add 1 CH3. What about the rest? So I can't add this and that. The only thing I can add is that. So, okay, so I'm now going to put another CH2 and a trailing bond. Okay, so I've taken that into account. And actually at this point, what I'm going to highlight to you is what I was going to say earlier. Whenever you see 2 triplets, whether it says NMR spectrum or in the table like that, whenever you see 2 triplets, it's a quick sort of way of realizing that actually if there are 2 triplets in the same NMR spectrum, that means there's this group present in that molecule. So 2 CH2s side by side, and you'll notice there are my 2 CH2s side by side. Yeah, so a quick trick is as soon as you see 2 triplets, assume that there's going to be 2 CH2s side by side. Anyway, let's continue. So that's been taken into account. That and that has been taken into account. Again, I can't add OH here because that would be the end of the molecule. Where am I going to add that? So I'm now thinking, well, if I add either of these, it's going to be end of the molecule and I won't be able to add anything else. So I'm thinking, okay, what if hold on, how many carbons have I drawn yet? 1, 2, 3. Hold on, how many carbons are being shown here? 1, 2, 3, 4, 5. But there are 6 carbons here. So that means I can add another carbon. Remember, a carbon will not show up in the proton NMR, okay, because it's got no hydrogens. And now to this carbon, I can add one of these, well, maybe I can add both of these CH3s. So watch this, because it needs 3 bonds. So if I say CH3, CH3, and then OH. Yeah, here. So I've taken that into account twice, and that as well. Now, that is what I think the molecule is, but immediately I'm thinking, and this is what I'm thinking, hold on, acidified potassium dichromate, yeah, oxidizes this. Will it be able to oxidize that? Well, hold on, it won't, because acidified potassium dichromate can only oxidize primary or secondary alcohols. This is a tertiary alcohol, and so it will not be able to oxidize that. And so what I'm thinking is, all right, well, let me just confirm whether I've got the right number of carbons and hydrogens. So 1, 2, 3, 4, 5, 6 carbons, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, okay, and 2 oxygens. That's fine. Okay, so, you know, in terms of the number of atoms, it seems fine, but what happens, or why will it, you know, how can I change it for me to be able to allow this molecule to be oxidized by potassium dichromate? At this point, if I was in an exam, I would draw a star at the top of the page, yeah, depending on if I've spent enough time on it. So if I'd spend 9 minutes or 10 minutes on it, I would draw a star, leave it like that, and move on, right? The only thing I would say is, just to remind myself, is potassium dichromate oxidized. Yeah, primary or secondary alcohols. The reason I'm putting this down is because, one, to remind me when I come back to this page, yeah, question mark, right? And secondly, to tell the examiner, if I don't get time to get back to this, tell the examiner that I do realize it's not going to be oxidized by the potassium dichromate, yeah? So they may or may not give you a mark for realizing that. I don't think they will, but at least, yeah, it'll give you an indication when you come back, okay? Now, when you come back to this question at the end of your paper, you now think, okay, well, look, obviously this is not going to happen, right? So what if I need to have an OH somewhere either in the middle here, which I can't, because that's not the, you know, information that NMR is giving us, or I need to have that OH somewhere at the end of the molecule. And I'm just thinking, is there an easy way? Oh my God, okay, so what if I move that to that oxygen, and that, so to that oxygen, so that OH will be there, and that CH3 is actually there. So what I'm going to do is I'm going to redraw it. I'm not going to just do, you know, leave with my arrows. I'm going to redraw it so the examiner knows that this is my final structure. Sorry, this is supposed to be an OH there. Yeah, just confirm 1, 2, 3, 4, 5, 6. Yeah. So that is the molecule, because now that primary alcohol will be oxidized, and of course it still fits in with all my molecular formula over there at the top. Now let's assume you didn't know how to do this. You could not get to that. This would still give you 8 out of the 9 marks. So this will be a mark. Okay, so that's a mark. That will be a mark to say that there's no C double bond O. Okay, you've realized that, and you've used the information from the IR. Okay, this will give you a mark eventually when you get to it, so the OH is at the end. Okay, and that's the mark that you will lose. Okay, if you'd left your structure as that. Okay, but anyway, so that's the mark. So that's the mark. 3.1, so singlet OH, that's going to be a mark for you. Okay, 2 triplets, okay, and 4. So when you've drawn those here, okay, that's going to be a mark together. 3.8, okay, that's going to be a mark, right? And then singular 1.1, that's going to be a mark for you, okay, that you've shown it. Okay, and the fact that there are 2 of them, that's going to be a mark as well. Okay, and then 3.2, that's going to be a mark. So can you see, every time you've drawn structures underneath, yeah, you would have got a mark. If you hadn't drawn that structure, you still would have got that mark together, possibly. And of course, the final mark is for your actual structure. And I think that probably just adds up to 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and so that's what you would have got. And that mark is the same, isn't it? It would have been a primary alcohol. Okay, so anyway, if you notice, look at how much work I've done, actual work, written work I've done, that, right? So it's not a lot, it's just a lot of thinking process. And I think I'm hoping that what you're learning from this is that not to panic when you see questions which seem difficult or which seem there's a lot of writing involved in it, yeah? There was not a lot to, not a lot to worry about, okay? So you think you know how to do these questions, right? Wrong. You've just become familiar with them. You won't actually know how to do them until you try them yourself. Try this very question. I'll put the question in the description below. Give it a go yourself. And if you can do it, then you can say you know how to do these type of questions. But practice some more, okay? To become experts at it. Because that's what you're aiming for, to become experts at these type of questions. And you can only do these by practicing, practicing, and practicing some more. Let me know what particular question you would like me to go through. And if you have any advice on how I can improve these videos, let me know. I'm all ears. And if you find these videos helpful, give me a thumbs up and consider subscribing. Okay? All the best. See you next Tuesday.